Okay, cool. Welcome. Today we are talking about how data will help onboarding institutions into staking. And yeah, since everyone here builds slightly different data products, I think it's quite nice if we give the chance to introduce yourself, the product you're building, and then in one word, what is staking data for you?
Okay, I begin. I'm Jack from Avascan. We build the Avalanche Explorer, the main Avalanche Explorer. And we are also the #1 source for staking validator data on Avalanche. And for me, one word for staking would be performance. Because this is what users and delegators and people that want to stake, because the validation is trustless on Avalanche, so you can give your stake to another node operator without slashing, without consequences. And so performance for node operators and validators, yes.
Slightly more than one word, but...
Yeah, but just explain the word, yeah.
That's fine.
Cool. I'm Elias, I'm the co-founder and CEO at Rated. We rate validators on Ethereum and validator operators for performance, and we host and are continuing to build a product suite that makes infrastructure data easy to work with for use cases like rewards accounting and performance benchmarking, and even just more generalized active set management if you're sort of a pool operator. And it's all underwritten by enterprise-grade data pipelines. And in one word, staking data, it's complicated.
Fair enough.
All right, hey guys. My name is Erik Ashdown. I'm the head of ecosystem at Covalent. What staking data means to us is Covalent takes full replicas of everything that's happened on 198 blockchains. So every transaction, every wallet, every state transition, if it happened on chain, we have it in a database. And then we decentralize. We're in the process of decentralizing that at the back end. So multiple validators running full historic replicas of all of these chains. What staking data means for us is developer readiness and performance. In order for our data to be useful, it has to be ready, it has to be accurate, it has to be usable day one. So that's how we look at it.
Cool. All right. So hope you have a good understanding how our panelists see staking data. I think the most interesting talking point would be what is decentralized infrastructure and holding data in a decentralized way. So maybe Erik, you can share your thoughts on that.
Yeah, absolutely. So how we look at decentralizing data is right now, all staking data, all data for the most part is centralized on GCP, on AWS, on some bare metal, and on some shared resourcing. The problem is if you look at what's happening in the space now, archive nodes are getting bloated. I don't know if you guys saw what Ethereum is doing, where they're actually depreciating archive nodes over the next few years. And when you see people talking about data infrastructure, like you see EigenLayer, you're seeing Celestia, which just launched, and they're saying that we are data availability. The problem is this data availability only lasts 8 weeks at max. And so we're looking at this from a holistic long tail perspective of how do we take this and how do we have multiple sources that will host this so the data is accurate, the data is secure, and there'll be multiple sources of truth. I think the biggest shame would be once archive nodes and all these things go away and everything is happening on chain, that there is no replica, there is nothing, something gets lost. So what we've been working on for the last couple of years is really taking all of this data, structuring it, making it cryptographically secure, and distributing it across a handful of validators, just to make sure that this stuff actually works, and then making sure that these validators can make money on the demand side of this by building these, by building APIs, by building dashboarding tools, and by coming up with multiple ways to extract the data from it. So the way we see data being decentralized is really, it has to be cheap, it has to be cryptographically secure, it has to be accessible, and there has to be redundancy in the supply in order for this to scale for the long run. Because I can't imagine, for taxation, if you want to do your taxes, I know nobody likes taxes, but if you want to do them and all the data is gone after 8 weeks, it's not really useful.
So if you're saying it has to be secure, it has to be like spread, what does it mean it has to be? Like, where is the demand? What do you think in terms of your clients? Like, we're talking about institutions. Like, who has actually this demand in this?
Yeah, so for us specifically, we have over 40,000 developers who are registered. I won't say we have 40,000 active developers on a daily basis, but we have over 40,000 registered, and we have thousands of developers active on a daily basis just using our APIs. And what's interesting is there are people who at scale will go to, who really want decentralized infrastructure. They want it to be effective, they want it to be cheap, they want it to be censorship resistant. You're seeing that this is factually working already in the RPC space. So it works with Pocket. You're seeing it works with things like Beware that are coming online. Anchor's been around doing this for a while. And you're starting to see this on the RPC space. The next space for this to happen is like the next place down the layer, which is data infrastructure. So I think there's a huge appetite for institutions who are looking to buy from the hosted solution. Like EY is one of our clients as an example. Like they built an internal tax product, and they get their data from us across all these chains. And what's interesting is we just said, hey, we are planning to decentralize this stack. They said, cool, that's good for you. We're very happy. Congratulations on this journey. We would rather pay money to this company that has SLAs, that has agreements, that has customer support, that has all these things. And we absolutely love the fact that you will be querying from a decentralized network where all the data is secure across all these node operators, because that's proof for us that there is redundancy in the data supply, right? And that's what they're looking at, these enterprises, is like redundancy in the data supply, because right now you're seeing, from a data infrastructure perspective, we have some clients who they'll use us for our APIs, and then they will have a second partner or second vendor who they'll use them for redundancy to make sure our data is the same. So this solves that problem at scale, and everybody along the supply chain makes money, and it solves everyone's problem.
Cool. Do you see the same demand, Elias? Like in?
No, I don't necessarily think that decentralization in data that way is that important. Basically, decentralization is like a way to do certain things, to be able to provide certain types of value, like data integrity being probably the most important one. And decentralization is a way to achieve that, but not necessarily the only way. So you could have, for example, like different cryptographic techniques that can get you like very close to having this infinite redundancy, or you can have probabilistic mechanisms that are like game theoretical, that guarantee this data integrity, or maybe even data availability and so on. So I really see kind of decentralization as one of the options to really bring to the market the type of value that like certain people are looking for, and like data integrity is obviously pretty much the most important one. And it's also, decentralization is you can't have it everywhere, because the fee stream to support this decentralization is redundancy. And redundancy means that you have like many copies of the same thing, and you basically need to create order of magnitudes larger fee streams to be able to support that. Otherwise, over a long enough time period, it's probably reverting back to centralization, if even you can generate like enough of a fee stream to support that like one hosted version and so on. So plus like all the hosted stuff and then centralized stuff, you can have like SLAs, and then SLAs are basically guarantees to data integrity. Now, can smart contracts consume data that way? Then probably not, right? But still, argument to be made that decentralization is, you can achieve it in different ways. It doesn't necessarily need to be a network that then all the nodes talk to each other in this expensive consensus mechanism, but again, you can have like optimistic mechanisms. So for example, we rolled out an oracle on Ethereum that brings some of the data that we curate onto the Ethereum execution layer, and we looked at the market and different options, and hey, like smart contracts really care about data integrity. Yeah. Because once the data gets affected on chain and it becomes available, then the downstream effects can actually are immediate and irrevocable. And the larger sort of the pool of capital that basically that data becomes an arbiter of, the larger the ramifications if things go wrong. So we looked at the market and then we said like, okay, well, for the use cases that we're looking at, centralization, probably like overkill, and we haven't proven that like there's a fee stream to support decentralization. So we're not going to put the cart before the horse. we looked at ZK and like different cryptographic mechanisms, and then we weren't really convinced that actually the gas, for example, required to pay for these operations, plus like all the sort of uncertainty and grayness in how like the actual proving happens, and the technology being like really too early, didn't convince us, and so we decided to go with an optimistic mechanism, which basically says, okay, well, here's like an on-chain SLA, we're like pledging a bond, really, we're making an assertion about something that happened on like data that might be on-chain or off-chain, but really the point is that anybody can go and access this data and replicate the result that we're asserting, and then say like, okay, well, we're making this assertion, but you have 24 hours to say that like, hey, you guys are asserting a bunch of crap. So if you can prove that to the arbitration court, then you get the SLA, effectively. So in short, I think decentralization is an important solution, but in our view, it should only come if you're actually able to support it and support it over the long term.
I think that are quite interesting definitions for staking data. I'm not sure about you, Giacomo. Like, do you have that problem at all at Avascan? Are you holding data? Is there a demand to hold data in a decentralized way, or are you just showing it what is on-chain?
Yeah, so I think there are a couple of things, but I would like to focus more on the staking, because we know we have staking-focused data. So, and the thing is, when we talk about staking data, we talk about Avalanche because that's what we index. Avalanche has a unique structure, and so basically the uptime of a validator is actually a perceived uptime. So I have a validator X in Switzerland or whatever. I can have a different perceived uptime of another validator Y in, for example, Istanbul, than another Z validator that it's in US. This is because just how the peer-to-peer network is done. And so basically, one way we can, at the beginning, we were just using our nodes. We had like 3-4 nodes, a couple of full nodes and a couple of validators. And we used to simply, just randomly select the uptime from one of those and just put that as an uptime. But sometimes we got issues like, well, my uptime is shown at 0, or my uptime is shown as at 10%, but maybe that was not actually true. Because the way the network subsamples validators for every block handles, you get a different perception of the network at every block. And so basically we started subsampling different validators and full nodes and asking these nodes what was their perception of the network. And so now we make an average, I think it's a ponderated average of those uptimes. And we have around from 15 to 30, depends on whether they are up, whether they have the port open, and so on. And this is how we just kind of try to decentralize data. This is the same thing that you can do when you have an explorer that is what we call a light explorer. So basically, we provide a Avascan as a full index explorer. It means that we index everything that is on. We try to parse data in every way possible. But users can also try to have their own vision of the network based on what our indexer compares. So basically, they can just go to our DevNet, it's called DevNet on RouteScan, that is our new EVM block explorer platform, and just input their RPC and have just what this RPC is looking at the blockchain. And so this is how we try to look at this. And looking also at node data and data integrity, this is something that is really like, we care about it very much, but there is a specific issue with that, is that nodes are expensive.
Yeah.
Are really expensive.
But on Avalanche, it's not all data about node performance is on chain, right? Like there's a lot being exchanged on the networking layer.
It's not on chain, but it's on the peer-to-peer network.
Yeah.
You need to log it.
That's right.
It's not. That's
right. And then it becomes like it's a weird issue, like with the data APIs on Ethereum, for example, where you have like the MEV Boost PBS world, where you have like actors intermediating block production, but basically all the historical state of what this relay, which is kind of like the load balancer between a node called the builder and the actual block producer, is centralized servers, and you're basically trusting on the good faith of maybe like 4 different parties to actually maintain the data and maintain data integrity. But you can imagine that as the industry grows, for example, then there could be multi-million-dollar disputes basically on whether this block was produced. It's SLA disputes, effectively, right? Was it produced appropriately? Did you attribute back to the expected fee recipient of a smoothing pool or whatnot what you were supposed to? And then your data that you're basing, like you can't have like a solid ground to actually be able to make a determination on whether that was true or not true. And so something like Covalent is building, for example, is like a super interesting solution for that particular problem. But then the issue becomes, okay, who funds that fee stream, right? Like relays are at to date, and it's like a year plus since they launched on Ethereum mainnet, they remain unfunded. There is no explicit business model behind relays. There's like, you know, maybe it will be on someone's good grace to actually like issue them grants or whatnot. And they've facilitated like, you know, north of 500 million rewards for validators, but they have made exactly 0. And they're actually not like, to your point, they're expensive nodes to run. Relays are nodes, and they're very expensive, so they have to run all kinds of simulations and transactions with the blocks, like make sure that the block is valid and so on. So there are like still like, being on the data integrity issue, like a lot of unsolved problems. And a lot of these are not necessarily technical problems, but they're actually like, okay, sustainability
they're
problems.
Business problems.
Exactly.
Go for it.
Yeah, no, I was also going to add to that. I think it's also interesting because like it's sort of early on and where we are in this space right now, and I think it's super interesting. And I'll speak a bit to the RPC and a lot of the infrastructure, is that you're seeing in a bear market, a lot of people are bringing a lot of stuff in-house and a lot of products are getting built. And no one is really, and some people are specializing. Like people are specializing at doing everything. Like Alchemy is a really good example of this, where I think they have like 15 products and they're all in-house, and it's like, how do we take all the infrastructure, bring it here? But what you start to realize as the space starts to scale is every layer is almost totally bespoke. Like if you look at RPC, I would even say there's RPC just in terms of like the routing and the execution, and there's RPC in terms of archive nodes. Like as the space starts to scale, you realize these are actually separate business models. Like, and it's not as evident early on. And as we start to scale and as we see this, that's where I think like we're having a good time, because we've sort of had this idea of where things are going and we're prepared for it. Like this has been what we've been preaching the same thing since 2018. Like we're not.
Also, there is something else that it's about data integrity, and I think could be important, but I'm not sure. It's about archival node with debug trace.
Yes.
So that is something that you know, we run our nodes in-house, and I used to say we are constantly like 80-90% cheaper than any other node provider, just because we have a really optimized supply chain between our node and our indexer. And so we find that like we ask 10 node providers come to us and say, okay, maybe we can give you the nodes. And then like 8 of them have the archive node, and just 3 of them have also the debug trace for all the chains that we ask.
But this is, I think, the issue that we're starting to see in this space is like, you're not in the RPC business, you're not in the database business, you're in the block explorer data visualization business.
Yes.
At scale, and especially because like you're hyper-focused on Avalanche,
yes.
I already know there's 30 production-grade Avalanche subnets.
Yes.
You will go out of business. Like, I'm not saying that negatively. Like, it's gonna. You'll have to hire like 30 DevOps people to do this.
No. Well, it's we run nodes for every Avalanche.
No, I know. But I'm saying is like if there's thousands, and it's like it's it's a crazy.
It's already there.
That's what I'm saying.
For Avalanche subnets, this is something that is really, it's really. I don't know what to say. It's really hard for people to understand, but for Avalanche subnets, we could support 1,000 subnets. It will scale really, really good.
Got it.
And it will scale much better than you guys, just because we are really focused on Avalanche subnets. That is the main question. But for block explorers or other chains, because we also index other chains, we have this data integrity issue. We just, sometimes we rely on some node providers because it costs a lot of money for us to index the same way that we do on Avalanche subnets on others. We basically ask the chain, as in the contract, we ask them and say, okay, in the contract, you need to provide an archive node with debug trace. This is because when Emin Gunsirer, the CEO of Avalanche, said to us 2 years ago, he said, well, guys, prepare, you are going to have 1,000 subnets with 1,000 TPS in 2 years. And we're going to run the calculation and forecast, and we're like, okay, yeah, but this is going to cost $400,000 per month. So we need to find some ways. So right now we are about 95% cheaper than Etherscan.
Yeah.
And we are about 80% cheaper than node providers, but just for some specific use case. I get that. And we are not general purpose.
Exactly.
We just, for our indexer, that is the best choice we found out right now, until now. So
for the record,
expanding on data integrity, I think
for the record, it's a great product. I will say it's a really good block explorer.
Yeah, thank you.
Expanding on data integrity, I think everything that is somehow coming on chain, coming from on chain, is somehow solvable to get right. Mm-hmm. What about data that is not on chain, like enriching data, like figuring out like who's running which operator and getting some extra information on your data. Like, how do you make sure that you maintain a certain degree of data integrity there, Elias?
Yeah, it's a multifaceted problem. There's no one answer that sort of applies to the full spectrum of the problem, and it's largely kind of like in the full spectrum. A lot of it is unsolved, right? And there's a lot of like interesting advances in cryptography and so on that we can actually employ. Like attestation schemes, like signing some message on the point of capture so that you can at least, like if you don't have like a decentralized set because of the fee situation that we just discussed before, you can have some guarantees and like, okay, I reported what I saw. The way we're dealing with this, first of all, we think, especially at the layer of the stack that we're sitting at, we think that providing like rich context is actually really important. The beginning of the company started out of a frustration that I had working at a company called Bison Trails. We're a very large node operator and validator as a service. We later were acquired by Coinbase. So through that whole arc, I felt like I was largely flying blind because there was so much data. There's a glut of data in the infrastructure layer, but like no outlet to actually like do something with that data, to benchmark my performance against my network peers, to account for rewards appropriately, to actually even like articulate what performance is. So all that contextual layer is really important. Now, in terms of how do you maintain integrity there's like a very dumb approach that actually works, which is sort of the community approach, right? Mm-hmm. Which is you basically create feedback loops so that people can come and tell you very quickly when you're making a mistake. Mm-hmm. The second thing is actually going for volume, right? There's one way, for example, to say that like I'm node operator X, and then you can have like a cryptographic scheme behind it and ask people to sign with their validation keys, which is something that they absolutely don't want to do.
No, well, they do it with us.
They do?
They do it with us.
In Ethereum, it's very complex.
Yeah, I know.
It's super complex. So maybe like the thing that you're sort of entering the beacon chain in is like an aggregator. Maybe you're like with a custodian. Maybe you're holding it yourself. Maybe like you want to do it with your Web3 signer, but people are like, well, I'm not going to touch my Web3 signer.
Yeah, because that is not perfectly enshrined in the network.
That's right.
On Avalanche, it's really easy. Just sign with your private key.
That's right. That's right. There's a lot of things that are very, very imperfect with Ethereum infrastructure and the way it works, but such is the world.
It's a plane that is
has been very open to the community because we're looking to serve node operators, we're looking to serve people that work with node operators and so on, and we're looking to serve like solo stakers as well. Just provide them with the context that helps them sort of operate their business or operation or hobby or whatever that is, and just draw feedback and then scale, right? So so that when you have like scale in terms of like drawing this context, in terms of identity, in terms of metadata, in terms of all of these things, then you can actually find where the doubles are. So if two people are saying I'm the same person, then you at least can surface where a problematic area might be. So for example, like this is to date, and also like people's goodwill. So people are actually like more honest than you'd think. And so to date, I think we're mapping 80% of the beacon chain's validator on 85 in terms of like identity or who they likely are and who they're associated to. And 20% of that is people self-reporting to us. But to date, we haven't found anybody that actually is misdisclosing who they are.
Goodwill is one thing, right? But like I imagine, like Erik, your product like cannot rely on goodwill. Like, have you faced this problem at all, or are you just taking data that is verifiable on chain?
No, man, we don't trust anybody. Don't even trust ourselves. Like so that we have a hosted solution, and we're in the process of, like I said, decentralizing our entire backend. So we built a couple products in-house, and this is how the network works at scale. One is our general product. Everything runs 2 blocks behind. So if you get data from us, it's always stale data, some people call it. What we do is we have something called a refiner that just randomly samples 1,000,000 blocks, and it like from all the validators to make sure that the data is the same across every validator. Like there is no room for error. There's no gaps. There's to make sure that if somebody like Chorus 1 is running it and Stakely is running another, that the data is exactly the same.
But that's the factual, right? It's not it's not the context layer. It's not the abstractions on top of the actual primary. This is checks on like the primary.
Yes.
Yeah.
This is actual historical data. And then there's another thing that we built. It's called a refiner that goes on top of this. And what that does is it just makes sure that there's no gaps. So if you query like I want to see 25 blocks from now, it runs an extra 100 blocks behind just to comb through to make sure there's no gaps in the database. So I think when you have these security measures that are built in, and this is how validators are earning rewards, and there are different operators on the network earning different rewards for doing different functions, I think you just have to incentivize people to do these and incentivize them properly. And as long as there's demand for this data on the network, it'll all work out. So we've been pretty focused on both sides of this, right? Like you can't just trust somebody at their word and say our data is the best data. We've seen that enough already. But the fact that there are people who have crazy data bills because they're buying from us and they're buying from a totally separate party because they need that redundancy is sort of the issue. And even then, at that scale, because Ethereum is public data and people will reconcile it differently in their database, you'll see that even with us and somebody else, the data is not the same. Like if I can openly say, what was the price of I don't know, some ape that sold 2 years ago at like on March 22nd, right? March 22nd, 2021. What was the price? It's a really hard question to ask. Because
that is an impossible. It is an impossible question.
But that's sort of it's an impossible question because the price. You know the answer.
How can you?
But this is sort of the problem. But if you have data integrity and like all the validators have the same, then there is some consensus on it on the historical level. If not, it's up to different people who have the same data in a database and how they choose to tag it. So the point is like it's up to the individual extracting the data. Like you guys would have something very different. Like you guys, it's up to you to make the decision, right?
Yes.
So
the thing is, we do it wrong, but we know it, but we don't know how else to do it.
There's no standard. There's no gold standard.
We pull some prices from CoinGecko, others we pull from liquidity, the DEXs, and we don't know actually what's the standard.
Yeah.
But that's an open question.
I think
price is relatively easy because it comes from multiple different sources.
But it's not the same.
It's not the same, but you could yeah, like you have different providers. What if you're the only one who has this data?
No,
I think this is the most interesting part of that story. We cannot answer that because we are out of time.
Stay tuned, guys.
So just wrapping it up, like real quick in 20 seconds, what are the challenges you see in data for your products, especially targeted to institutions?
So the problem for us is to actually have more granular data. And it's something that we're working towards. But for Avalanche, a lot of institution, Avascan, through proxies, to understand more about what's happening on single validators and overall the uptime and so on, trying to have a single request. Also for compliance reasons, there should be different data providers. I think it's at minimum 3, so that's what we're looking at.
Yeah, I see a lot of opportunities rather than challenges, but opportunities are challenges in and of themselves, right? To unlock the opportunity, you have to go through a certain set of challenges. But like, I think the most interesting opportunity in terms of like how we work with data, how we touch with data, and so on, is actually like introducing cryptography in the data pipeline to have guarantees in terms of integrity. Maybe you can't get like full guarantees that like it is exactly reported as I saw it and goes through a set of abstractions. So then there's an assertion at the end, that's like a data pipeline. And then there are like, 3 or 4 very distinct steps in which I have a sense that you can use cryptography to actually get like a really good outcome in terms of the integrity guarantee that you provide at the end. Maybe it's not 100%, but maybe we can get to like 99%, which is pretty darn good. So I'm excited to be exploring that area moving forward.
Me too.
What was the question again? Sorry. I was they both had such detailed answers. I was like, okay.
What is the challenges you see or opportunities for your product?
Okay, challenges, opportunities. I'll split this into 2 because we have a hosted solution and we have a network. On the network, what's really exciting that we've been working on is the great migration. So we're actually going to start bringing some of this revenue we're making from these SLAs and from these customers on chain. I think I'm personally bullish about a lot of decentralized infrastructure in the space, on the data layer, on the RPC layer, and I think we're going to see decentralized SaaS very soon. It's going to be super exciting to see what it sort of sets a standard. Like DeFi is easy, I say with air quotes. Infrastructure is really hard, and I'm really excited for that on the network side. So we're migrating that next year. On the other side, it's just bear markets are awesome. I hope the prices come back down and everyone gets upset and we get another year of depression because it allows us to build better products and not without as much noise. So for us, it's been great. And yeah, I think I'm excited to see a lot of the new types of infrastructure projects start coming online. And I don't want to say consolidation, but specialization. Like I'm excited for people to stop trying to do everything in-house, us included. Like there's a lot of things where I would like to, we've killed a couple projects already and hopefully we'll kill more. And just to see deeper partnerships with people who are focused on doing 1 or 2 things really, really, really well. Like that is the thing that makes me super excited.
Cool. Yeah, I'm super excited what comes next. So thank you all. I think it was very exciting. So.
Thank you. Yeah. Awesome. Thanks, guys.
Thanks for having us.